Hello children. It has been a long, I think 2 weeks time that I had conducted the class. I think last week I had conducted the test, and because of it, I think there had been a gap of around 14 days. Okay, if you remember the last interactive class that we had, I think in Google Meet that I had conducted, where around 30 to 34 of you had actually joined. But still, out of that, many of you were not able to join them. And then for those people who were not there, a very brief discussion about what we already have discussed in that interactive session. I had started with this chapter called chemical bonding. So in this chemical bonding, it is about how different atoms will come and bond with another atom to form a molecule. That means a formation of a molecule is taking place when two different atoms will adjust themselves, will carry out certain modification. That you see modification, what I mean by modification, and they will form a stable molecule. And that is what they do it by either loss of electron or by gain of electron. And this loss and gain of electron is, if I use a single word, then I can say that loss and gain of electron is transfer of electrons. So that means those molecules which are formed by transfer of electrons are called covalent compounds or covalent molecules. Sorry, they are called electrovalent molecules. Whereas those which are formed by sharing of electrons, they are called covalent molecules or covalent compound. So that means our chemical bonding chapter is about the study of these two kinds of compound. One is electrovalent compound and the other one is covalent compound. But in addition to this electrovalent and covalent, a little extension of covalent bond is also third kind of bond, which is called coordinate bond. Coordinate bond. That also we'll discuss. So that means we'll discuss electrovalent bond or electrovalent compound, covalent compound, and third one, coordinate compound. Don't forget, coordinate compounds are also called dating bonds, or they are also called dating compounds. Alright, then I will start again, even though we have discussed it a little bit about, I'll start with electrovalent compound. Or electrovalent bonds. So bonding, chemical bonding, the other one is those molecules are formed by using this electrovalent bond is what is called electrovalent compound. Now, usually electrovalent compounds, electrovalent bond is formed between metal and non-metal. As already discussed before, that metals have extra electron on the outermost shell. Metals have in the outermost shell either 1 electron or 2 electron or 3 electron, valence electrons. Whereas non-metal have either a 7 electron on the outermost shell or 6 or 5. Now, as we discussed in the previous class, they have already deficit of electron. They have less electron. The one which has 7 always says, okay, why I did not have one more, so that we can octate. Okay, don't forget, we already discussed about octate and duplicate rule also. So octate means most stable. See, those who have outermost shell 1, 2 or 3, they are not stable. Those who have 7, 6 and 5, they are also not stable, because the stability is brought about by outermost 8. But in some cases, in some molecules, it is 2 duplicate. So they are not happy, even they are not happy. So the one which has 7 will always say, why not one more? The one which has 6 on the outermost shell, why not 2 more? The one which has outermost shell 5 will say, why not 3 more? So that they will cooperate. Same way, the one which has 1, 2 or 3 electrons, they'll say, oh, why I had 1 extra, why I had 2 extra, or why 3 extra. That means metals are always looking to shred this electron, throw this electron. Non-metals are always looking for taking electrons. So that's why when this metal and non-metals are coming close to one another to form compound, electrovalent compound, see what happens? Very nice partnership. This metal have outermost shell 1 electron and this non-metal have outermost shell 7. So this 1 electron gets transferred to that 7. So when this 1 is transferred, this metal also will have outermost shell 8, because the next shell will be having 8 outermost shell. This which had 7 now also becomes 8. Now both of them become octane. Now both of them become happy. Both of them become stable. Then same way, the one which has 2. This 2 is transferred there, the one to the one which has 6. So this becomes octet, even that becomes octet. Same way, the one which has 3 gets transferred to that which is 5. So that means from 3, as this is getting transferred, this also becomes octet, that also becomes octet. So that means the basis of formation of the electrovalent bond is a transfer of electron, and transfer of electron always takes place from metal to non-metal. Okay, now I should also tell you that when electrons are transferred, before we go on to I think 3 which are mentioned in the syllabus, you should know what happens. Whenever any metal, okay, if it is losing one electron, see, metal is stable, number of electrons and protons are equal, but when one electron is lost, this metal will form and plus one electron lost, that means now in this case, metal will have one proton extra, right, one positive charge. And this is what we call as cation. This is cation, a single valent, as you can see, it is a monovalent cation with the valency of 1. And similarly, if a metal is losing 2 electrons, it will form M plus 2 or 2 plus. So this one is also a cation. It has lost 2 electrons. The same way, a metal may also lose 3 electrons. If it loses 3 electrons, then it will form M plus 3. And by the loss of more than 3 electrons, not possible to maximum electron, which can belong to the 3. Same way, whenever a non-metal, okay, let's talk about one non-metal X. Whenever non-metal is gaining electron, it will form X minus, now it has 1 electron extra. Or it may in some cases gain 2 electrons, so then it will form X plus 2. And it may also gain 3 electrons to form X plus 3. Now, these are all positive ions which we call cations, and these are all negative ions and we call them anions. So, these are anions, negative. So these are all negatively charged ions, and this negatively charged ion is what we call as anions. Positive charged ions are called cations. So that means during the formation of the covalent compound or covalent bond, there is always the formation of ions. So ion formation, why ions are formed? Ions are formed so that they will attain stability. Don't forget this loss of 1 electron will give it stability. So it means atomic cell 8. Gain of 1 electron will give it stability, atomic cell 8. And this very stable configuration is what will help them in formation of the electrovalent bond. Now, the syllabus mentions electron dot structure of 3 electrovalent compounds. Now, I'm going to discuss this 3 electrovalent compounds, electron dot structure. They are sodium chloride first, second one is magnesium chloride, and the third one is calcium oxide. So, these 3 compounds, let's see what is this electron dot structure. Okay. Now, in electron dot structure, you can make the structure also full with shell, all shells will be shown, but that is not electron, that's what the structural representation. But then in electron dot, we only use the electrons of the outermost cell. Okay, first let me start with electron dot structure of sodium chloride. How is the formation of the molecule sodium chloride take place with the combination between sodium and chlorine? Okay, I am going to show you here. Sodium, you know sodium in the periodic table first chapter is the 11th element of the periodic table. So 11th element means the outermost cell of sodium is 281. In fact, outermost cell is 1, configuration is 281. Chlorine is the 17th element. 17th element means it is 287. Okay, now I wrote the configuration, but then in our electron dot we don't require the configuration, we require only the electron in our outermost cell. Sodium has 1. So that means if I have to write sodium, so now I have to represent the electron of sodium in the form of dots. So when you write this one dot, I write here. Somewhere I can write anywhere around it, so let me make it somewhere here. This is what is the outermost electron of sodium. This is the valence electron of sodium, only 1 electron. Then chlorine, also outermost cell, as you can see, is 7. And here also represented by a dot. But to differentiate between the electron of sodium and chlorine, let me represent that by a cross. I will make a circle also, but you know, a representation of these. These are the representation 1, 2, 3, 4, 5, 6, 7. You can see 7 electrons. Now, both sodium and chlorine, they are not happy. This is outermost cell 1, that is outermost cell 7. They are not happy because they are not stable. Sodium will become stable if it can lose, if that electron is lost, then outermost cell becomes 8. So that is why here it is. Sodium, what it will do? It will transfer 1 electron to chlorine. See, chlorine is in need of 1 electron. Chlorine is in need of 1 electron and sodium has 1 extra electron. So what sodium will do? Sodium will lose 1 electron to form Na+, as we already discussed. Here it is. Sodium atom, stable. Now, as it loses one electron, it forms sodium ion. Now, sodium ion, as it has lost one electron, now again, this sodium has already now lost one electron. And this sodium will be losing one electron, so it will form Na plus. Okay, now let me write down here Na plus. So this is Na plus, and Na plus has one outermost cell. Now our outermost cell is not 1, now our outermost cell is 8. So 1, 2, 3, 4, 5, 6, 7, 8. Now you can see sodium is very happy, outermost cell is 8. In the same manner, chloride already got one electron from there. One electron was donated by sodium. As chlorine got one electron, so now it becomes Cl minus. Now, as it got one electron, now the outermost cell of chlorine is becoming 8 now. 1, 2, 3, 4, 5, 6, 7, and 1 electron which it received from sodium. So that's what I'm representing by a dot. So if you really count, then the total number of electrons in chloride ion is what is. This is what is chloride ion. Is what is 8. So this one is also 8. That is also 8. Now this is sodium ion. Sodium ion, not sodium atom. That was sodium atom. Sodium ion has outermost cell 8. Chloride ion also have outermost cell 8. Now both of them become stable. And since one is positively charged, the other one is negatively charged. So now a very strong force of attraction between positive charge and negative charge takes place, giving rise to a very strongly bonded molecule, which is called sodium chloride. So if you are asked to make an electron dot structure, see such an easy way of representing the formation of sodium chloride. Now, why this is electrovalent? Because transfer of electron took place from here, the transfer took place there. So one electron got transferred from here to there. And during the formation of that molecule, there are always formation of charged ions, positive ion and negative ions. This positive ion and negative ion, that electrostatic force of attraction between them is what will bring them closer to one another, and that is why we say electrovalent bonds are very strong. In fact, they are the strongest bond as compared to all other chemical bonding, electrovalent. This is how sodium chloride. This is what is electron dot representation of sodium chloride. Now let me go to the next one, magnesium chloride. Magnesium chloride. Now, why I am writing word is because many times there will be a confusion. See, what is that confusion? Magnesium have configuration up to 8 so outermost cell is 2. And chloride have outermost cell to 8 7, the outermost cell 7. Now, magnesium has 2 electrons outermost cell 7, and chloride has only 7. In fact, it requires only 1, but then magnesium has to give 2 electrons. And chlorine cannot take 2 electrons, it can take only 1 electron. So that means a partnership like this cannot be formed because both must be stable. So 2 electrons must be given somewhere. That's why I wrote it this way is because you'll understand it even better if you can write the formula of magnesium chloride. Magnesium chloride, magnesium balance 2, chloride balance 1, 2 and 1, 2 will go there means 2. So that means magnesium chloride can be written as MgCl2. Now from there it is very clear that the total number of chloride or chlorine is 2. One magnesium actually combines with 2 chlorine. So then this is magnesium outermost cell 2, 1, 2 electron dot structure. Chloride 1, 2, 3, 4, 5, 6, 7. But there is one more chlorine. 1, 2, 3, 4, 5, 6, 7. Not happy, outermost cell 2. Not happy, outermost cell 7. Outermost cell 7. Now, magnesium wants to shred this 2 electron. So when magnesium shreds this 2 electron, magnesium will lose 2 electron to form Mg plus 2. Now you can see magnesium cation form. Magnesium. Now it will lose that 2 electron. So when it is losing 2 electron, it is forming Mg plus 2. Now Mg, as this 2 electron lost, now outermost cell is 8. 1, 2, 3, 4, 5, 6, 7, 8. Now magnesium has outermost cell 8. Now there are 2 chlorides. Okay, let me write down. Now chloride. What happens to chloride? This chloride will be gaining 1 electron. So as it gains 1 electron, it forms Cl minus. But don't forget, the same thing happens here also. So one chlorine atom becoming a chloride ion. In fact, that chloride ion will form. So 2 of them are there. That's why I represented this one with only 1. But same thing is happening here also. That's why if I multiply the whole equation by 2, it becomes 2 chloride, 2 of them. this becomes 2 electron, 1 electron there, 1 electron here, and this 2 chloride ions, this and this. So this is what is representation of 2 chloride ion. So that's why if I write down here 1, 2, 3, 4, 5, 6, 7, and 8th one electron from there. Then here, from here to 1, 2, 3, 4, 5, 6, 7, and the 8th one here. Now this is also a chloride ion, this one is also a chloride ion. So this one magnesium ion, chloride ion, chloride ion. Now you can see this is 8, this one is also 8, this one is also 8. Now this when combined together, so it forms. And don't forget positive charge, negative charge, a very strong bond in this form. So it forms electrovalent molecule or ionic molecule. Electrovalent, another name is ionic molecule. That is what is magnesium chloride. So this is what is the formation of magnesium chloride. Let's call it as by representation in terms of electron draw. Now let's go to the third and the last electrovalent compound, which is in your syllabus. And that is calcium oxide. Okay, calcium oxide, calcium valency 2, oxide valency 2, produce cathode, so formula is calcium oxide. Now very next representation is very easy one, calcium. Configuration of calcium is 2, 8, 8, 2. In fact, calcium happens to be the 20th element of the periodic table. It is in period 4 to at least 20 you are learning. So potassium is the 19th one and calcium is the 20th one. Oxygen, atomic number is 8. So configuration is 2 and 6. So nice partnership. Now this is having extra 2, this is having 2 less. So from here it gets transferred there. So very simple and easy. So then let's see calcium almost at 2. Let me represent like this, calcium 2, not happy, not stable. Oxygen almost at 6, 1, 2, 3, 4, 5, 6. Okay, here it is, 6, not happy. Then what calcium will do? Calcium will lose 2 electrons to form calcium cation here, C plus 2. Oxygen will gain that. Oxygen will gain 2 electrons to form O minus 2. So then very nice, 2 lost, 2 gain. So then calcium now, if it is losing 2 electrons forming calcium ion, now having the outermost set of 8, 1, 2, 3, 4, 5, 6, 7, 8, stable octet configuration. Oxide already had 1, 2, 3, 4, 5, 6. Now 2 electrons from here got transferred. So here you are, 2 electrons. Now this is also your stable configuration, 8 and 8. Now oppositely charged, very strong force of attraction. That is what we call electrovalent bond or ionic bond, and the compound calcium oxide is formed this way. Now you also have to discuss some properties, characteristic of electrovalent bond, but I think I will discuss that characteristic together when we discuss the difference between electrovalent and covalent. Now I will go to covalent compound. Now let us see the second type of bonding, and that is called covalent compound. And usually covalent compound will take place when there is a combination between non-metal with another non-metal. Now you know that outermost shell of non-metals either 5, 6 or 7, and this also 5, 6, 7, because both of them are non-metal. Now this cannot donate it to that, like in case of the electrovalent compound. So both of them are looking for electrons. So cannot be transferred. You cannot transfer from here to here. So transfer not possible means electrovalent is not possible. So the only possibility now is that they will do some adjustments such that both of them are satisfied. Both of them become octet, stable. Now in such cases what they will do is they will have to, the only option which is left is they will have to share electrons. And this sharing of electrons is what will take place between the two, sharing. Now I will discuss directly with taking into consideration the compounds which are in your syllabus. Now in fact you have altogether 6 of them in your syllabus, covalent, even though you had only 3 in electrovalent, but covalent you have 6 of them, and they are hydrogen, and then you have nitrogen, then you have oxygen, you have chlorine, ammonia, carbon tetrachloride, methane. These are some of the compounds which you have to discuss. Alright, now taking into consideration how they will share. Okay, I'll start with the simplest one, hydrogen. Let's discuss hydrogen molecule. And don't forget, hydrogen molecule is formed by combination of one hydrogen with another hydrogen atom. Two hydrogen atoms are combining. You know, configuration of hydrogen is 1, outermost shell of hydrogen is 1. So outermost shell of this hydrogen is also 1. So that means if I make the electron dot structure, this hydrogen have 1 electron in the outermost shell, and this hydrogen also have 1 electron in the outermost shell. Now transfer not possible, you cannot transfer from here to here. And yes, I should tell you that hydrogen will not be looking for octet configuration. Hydrogen is satisfied with duplet configuration. Hydrogen is very happy with only if it has outermost shell 2. But even that 2 it doesn't have. It cannot transfer, because if you transfer it will be left with nothing. Same thing, if you transfer from here it will be left with nothing, even though the other one becomes duplet. So the only way that is possible now here is they will decide to share electron. Come on friend, let's share. I have 1 electron, you have 1, let's share the electron. Now when there is a sharing, there is no formation. Now I cannot write sharing means loss of electron or gain of electron. It is not, because here there is no loss or gain of electron taking place. So that's why no formation of ions, that very strongly charged positive and negative charge which was formed there in electrovalent will not be possible in covalent. So that is why the only possibility that they will share, and as such there will be no loss of or gain of electron. So that is why no charge particles are formed. So what they will do? They will share the electrons between them. Now here share, that means friend, you can use my 1 electron, and when I need I will be using yours. So there sharing of electron has taken place between this hydrogen and hydrogen. Now when there is a sharing of electron, now if same thing can be, even though this is electron dot, so if you represent, then usually hydrogen in the other form, structural form, is represented like this. This is another hydrogen, here it is. Now usually, yeah, we make a circle like this. Now this hydrogen when you count 2, and that hydrogen also when you count it will be 2. But here in electron dot we will represent it this way only. So 1 electron of this, 1 electron of this, they will share. Now between them two, a very mutual, I would call it as partnership is formed. Mutual, because he is contributing 1 electron, even the other one is contributing 1 electron. Why am I using the word mutual is because when you go to the third kind of bonding, coordinate bond, you know that mutual sharing of electron will not take place. So that's why, but covalent compound there is a mutual sharing of electron, mutual, 1 from 1, or if this is giving 2, the other one also has to give 2. If he is giving 3 electron, the other one also has to give 3 electron. So then mutual sharing of electron. And how many pair? Now don't forget, I am talking here about pair of electron. 1 pair of electron is shared, and if 1 pair of electron is shared, 1 pair of electron shared means this will give rise to a covalent bond which is called single covalent bond. So that is why covalent bond is of 3 types. When 1 pair of electron is shared, then single covalent bond, single, 1 pair, single. When 2 pair of electrons are shared, like in case of oxygen to oxygen, 2 pairs of electrons will be shared. And when 3 pairs of electrons are shared, then we call it triple covalent bond, single covalent bond, double covalent bond, triple covalent bond. Now, as there is sharing of electron, a single covalent bond is what is formed. That means a covalent bond is represented by a dash. Single dash means single covalent bond. Yeah, 1 pair of electron, single covalent bond. 2 pair of electron will be represented by double dash, like this. And 3 pairs of electron will be represented by 3 dashes, like this. So single covalent bond, or a double covalent bond, or a triple covalent bond. Now this is what is the formation of hydrogen. So hydrogen, as you can see, 1 dash. So you will see this kind of dashes plenty in organic chemistry. Our last chapter is organic chemistry. This dash plays a very significant role, especially when we are making the structure. So don't forget, now dashes that you see is nothing but covalent bond. But 3 kind, either it is a single dash, or maybe a double dash, or maybe it can be a triple dash. So the first one which is mentioned in your syllabus is hydrogen. Okay, let me show you here only the second molecule, chlorine. Chlorine is formed between one chlorine atom with another chlorine atom. Chlorine configuration is 287, 287. Now you can see outermost shell 7 and 7. Both of them are unhappy, cannot be transferred also. So what we will do now? Electron dot structure, 1, 2, 3, 4, 5, 6, 7. One more chlorine, 1, 2, 3, 4, 5, 6, 7. Since you cannot transfer, now what they will do? They will share a pair of electron here, share. Now when you are counting for this chlorine, 1, 2, 3, 4, 5, 6, 7, 8, you can count that also because they are sharing now. And when you count for that other chlorine, 1, 2, 3, 4, 5, 6, 7, 8. Now both of them have become 8. They shared one pair of electron. That is why I can represent this as Cl-Cl, single covalent bond. Again one pair of electron. Like in case of hydrogen, here also. And hydrogen was duplet configuration. Hydrogen was very happy with 2 electrons. Chlorine is happy with 8 electron. Octet configuration, duplet configuration. So then you can see still between chlorine and chlorine, it is a single covalent bond. Now, strangely oxygen is not there in a syllabus. I said oxygen is not there. But then next one is nitrogen. Let us see nitrogen molecule now. Third one. Nitrogen is a combination between nitrogen atom to another nitrogen atom. Nitrogen configuration, atomic number is 7, means it is 2, 7, this also 2, 7, 2, 5 and 2, 5. So outermost cell is 5, not happy. So here if I make the structure of nitrogen 1, 2, 3, 4, 5, and this nitrogen also 1, 2, 3, 4, 5. So here I have made the structure of nitrogen. Now the only way in which they will get a stable configuration is by sharing electrons, and they will share all together. Here it is, 3 pairs of electrons they will share. Now if you count for this nitrogen 1, 2, 3, 4, 5, 6, 7, 8. This nitrogen is 8. That nitrogen also 1, 2, 3, 4, 5, 6, 7, 8. Octet configuration. Now both of them are octet configuration, and therefore nitrogen is represented by, now look at this, triple covalent bond. Oxygen, if oxygen was there in SLFS, it would have been a double covalent bond, but then not there. So nitrogen, triple covalent bond. So this is what is triple covalent bond in nitrogen. Now we have seen the covalent compound formation between same kind of atom, hydrogen to hydrogen, chlorine to chlorine, nitrogen to nitrogen. 3 of them. Now 3 more are there in SLFS where the combination of atoms are not same, they are different. So again, here I showed you single covalent bond, duplet, octet. That one is triple covalent bond, formation of octet configuration. Now let's see the remaining 3 also, the covalent compound. Then the first one is ammonia. Okay, fourth one. In ammonia, the combining atoms are not same. Now please understand, ammonia is important because when you go to coordinate compound, ammonia and water, this two is what will be playing a very important role. Ammonia becomes ammonium and then water becomes hydronium. So that's why structure you have to do it carefully. Now the combining atoms are not same. So one nitrogen, as you can see, is combining with 3 hydrogen. Okay, let me make now the structure, and don't forget this is 2, 5 configuration, and hydrogen, outermost cell is 1 for 3 of them. Okay, now let me make the structure. Nitrogen has 1, 2, 3, 4, 5, outermost cell 5. Hydrogen, 3 of them are there. Here hydrogen, I am making a cross to represent that electron of hydrogen, which is different from this one. Let me write another hydrogen here, another one. Let me write here third hydrogen here, like this. Hydrogen is not happy, it has only 1 electron. All 3 hydrogen, you can see 1 electron, not happy. Hydrogen is very happy with duplet configuration. Nitrogen not happy because outermost cell it has 5 and nitrogen requires 8. So a very nice partnership between this 3 hydrogen and nitrogen will be formed, and that is by sharing of electron. Now see how they will share electron. This atom of hydrogen will share 1 pair of electron with that nitrogen. So hydrogen is very happy now, duplet. Then same, this hydrogen also will do the same thing. Here it will share 1 pair of electron with nitrogen, and this hydrogen also will share 1 pair of electron. Now if you count hydrogen, 2, duplet, very happy, this is duplet, this is duplet. Hydrogen is very happy, it is getting the stable configuration. Nitrogen, if you count 1, 2, 3, 4, now you can count for that also, 4, 5, 6, 7, 8. Nitrogen is also happy now because nitrogen is also getting an octet configuration. Now we have 3 single covalent bond. Now don't say triple covalent bond, it's not triple because sharing is not taking place between the same hydrogen and same nitrogen. 3 different hydrogen with same nitrogen. That is why when I represent this, then it will be like this: single covalent bond, single covalent bond, single covalent bond. So ammonia is NH3 is represented like this: nitrogen with single bond and single bond. Yeah, this electron which I use for nitrogen is used for formation of bond. That is why the pair of electron that you see is what we call bonded pair because they were used in the formation of covalent bond. Here one covalent bond, single, second one, third one, 3 covalent bond. That is why this electron pair of electrons, these are pairs of electrons which are called bonded. They were used in the formation of bond. But you can see there is also one pair of electron which is not used in the formation of bond. Here on the top, this electron was not used in the formation of covalent bond. That is why such electron which are not, pair of electrons are not used for the formation of bond, covalent bond, is called lone pair. Lone means alone. Nobody took them for formation of bond. So that is why this is what we call lone pair of electrons. Again, lone pair plays a role now in the formation of coordinate bond. So keep in mind. So this is what is your formation of ammonia molecule. Now next one is methane and carbon tetrachloride, which are very, very similar. In fact, I will simply do one on the left and the other one on the right. Okay, let me write this fifth one, methane, and the other one, let me do it here, sixth, carbon tetrachloride. So which are very, very similar. So it is the formation between carbon and hydrogen. Carbon you know is 2 and 4, atomic number is 6, and hydrogen you know is 1 and 4 of them. So similarly here also carbon having 2 and 4, and hydrogen, sorry, chlorine 2, 8, 7. So outermost shell is 7. Here outermost shell is 1. Okay, carbon if I make a structure 1, 2, 3, 4. Not happy. Outermost shell it has 4. It is not happy. But there are 4 hydrogen. Now here one hydrogen, let me make it here. Second hydrogen, let me make it here. Third hydrogen, I'll make it here. And fourth hydrogen, I'm going to make it here. Now to get a duplet configuration, hydrogen will share a pair of electron with here. Here another hydrogen will share here, third hydrogen will share here, and the fourth hydrogen will share here. Now all hydrogen, as you can see, they are duplet. They are very happy, stable. And if you see carbon, count carbon 1, 2, 3, 4, 5, 6, 7, 8. Even carbon is happy now. It is getting octet configuration. So that means carbon as well as hydrogen, both of them are becoming now stable. Then means if I represent this structure, then carbon with a single covalent bond, here another single covalent bond, third single covalent bond, and the fourth single covalent bond. This is what is the structure of methane. CH4 is methane. 4 single covalent bond. Both are becoming stable. Same thing happens with carbon tetrachloride also. Carbon, okay, outermost shell 4. Just now we discussed that, 4, outermost shell 4. Chlorine, 4 of them are there. 4 chlorine. Okay, here let me represent one chlorine. 1, 2, 3, 4, 5, 6, 7. Chlorine halogen, so outermost shell 7. Here is another chlorine. 1, 2, 3, 4, 5, 6, 7. Third chlorine. 1, 2, 3, 4, 5, 6, 7. And the fourth one, 1, 2, 3, 4, 5, 6, 7. Now none of these people, these atoms are happy. Now to become happy, they have to be stable. So what they will do? They will share a pair of electron here. Now chlorine, if you count, it will become 8. 7 plus 1, 8. Here this also shared, this also shared, and this also shared. Now if you count each of the 4 chlorine, they are 8 octet configuration. And carbon, all carbon, if you count 1, 2, 3, 4, 5, 6, 7, 8. Octet configuration. So that makes it carbon with chlorine. Single covalent bond, single covalent bond, single covalent bond, and single covalent bond. This is carbon tetrachloride. In organic, same carbon tetrachloride, we call it as tetrachloromethane. But that we'll learn it in organic, you don't need to worry. Now simply learn it as carbon tetrachloride. See, 4 single covalent bond. This completes your 6 covalent molecules which are mentioned in your syllabus. Now next is your syllabus mentions about the properties of electrovalent compound and covalent compound, and also differences between the two. So if you know the properties, you know the difference also, or if you know the difference, you know the properties. So maybe in the next class I'll be discussing that. And yes, one more thing we have third bonding. We have discussed covalent bond and electrovalent bond, but there is also a third one which is called coordinate bond. I think in our next class, I think that will be the concluding part of this chapter. I'll be discussing coordinate bond, the properties of electrovalent and covalent, and also the differences between the two. And yes, most importantly, the formation of hydronium ion and ammonium ion. Okay, thank you very much, and bye bye.